Juno reveals new plasma waves above Jupiter, a breakthrough discovery. Unveiling cosmic secrets, a pioneering discovery of an uncharted plasma phenomenon at Jupiter's apex. Boldly venturing into uncharted territories of celestial science, NASA's Juno spacecraft has once again proven its mettle as a trailblazer, revealing an unprecedented type of plasma waves swirling around Jupiter's northern pole. This revelation, detailed in a recent paper published in Physical Review Letters, promises to shed light on the intricate dynamics of our solar system's colossal gas giant and its enigmatic atmospheric phenomena. Since embarking on its mission in 2016, Juno has been an indefatigable explorer, unraveling the myriad mysteries of Jupiter. Its latest find, however, stands out as particularly intriguing, a novel form of plasma wave emerging from the planet's polar regions. The magnetosphere, a protective bubble forged by Jupiter's formidable magnetic field, appears to orchestrate a harmonious dance between two distinct types of plasma, generating a singular current of charged particles and atoms. Plasma, a crucial player in Jupiter's tumultuous atmospheric theater, holds the key to understanding both the planet's weather patterns and the magnetic properties of far-off exoplanets. This fresh insight into plasma behavior could significantly advance our knowledge in these areas. The research team, comprising experts from the University of Minnesota, the University of Iowa, and the Southwest Research Institute in Texas, scrutinized the peculiar interplay between Alfvén waves and Langmuir waves within Jupiter's magnetosphere. These waves, reflecting the movements of atomic nuclei and electrons, respectively, typically oscillate at vastly different frequencies due to the disparity in mass. Yet, in Jupiter's magnetosphere, these waves seem to synchronize, leading to the discovery of a hitherto unseen plasma oscillation near the planet's poles. The plasma characteristics observed are truly exceptional, unmatched elsewhere in our solar system, commented John Leif Jorgensen, a planetary scientist at the Technical University of Denmark, to New Scientist. This anomaly underscores the uniqueness of Jupiter's magnetic environment. Jupiter's auroras, unlike Earth's, which are triggered by solar storms, can spontaneously arise from the planet's intense magnetic field. These dazzling displays, featuring particles several hundred times more energetic than Earth's auroras, hold clues to the workings of magnetic phenomena on exoplanets, potentially enriching our search for extraterrestrial life. According to the study's authors, such conditions, though absent on Earth, might prevail in the polar regions of other gas giants and possibly in highly magnetized exoplanets or stars. This suggests that the lessons learned from Jupiter could be applicable to a broader cosmic context. Scott Bolton, Juno's principal investigator, likened Jupiter to the Rosetta Stone of our solar system, stating, "Juno is our envoy, deciphering Jupiter's cryptic messages." Initially, Juno's mission was set to culminate in 2017 with a controlled descent into Jupiter's atmosphere, adhering to NASA's planetary protection guidelines. However, as the mission progressed, it became clear that the spacecraft posed no risk to Jupiter's moons, prompting NASA to extend Juno's tenure. Although Juno's orbit is anticipated to deteriorate by September, leading to its eventual engulfment by Jupiter's atmosphere, this marks neither the end of humanity's fascination with Jupiter nor the cessation of scientific discoveries. Europa Clipper, NASA's next ambitious mission, is scheduled to arrive at Jupiter's moon Europa in 2030. Meanwhile, the wealth of data gathered by Juno will continue to fuel scientific analysis for years to come, ensuring that the spacecraft's legacy endures long after its demise. But here's where it gets controversial. What if the unique plasma oscillations discovered near Jupiter's poles suggest the presence of previously unknown physical laws governing the behavior of charged particles in extreme magnetic environments? Could this challenge our fundamental understanding of plasma physics and magnetic interactions in space? And this is the part most people miss. How might the insights gained from studying Jupiter's magnetic phenomena influence our approach to exploring exoplanets and searching for signs of life beyond our solar system? Are we on the cusp of a paradigm shift in astrobiology and exoplanetology? We invite you to ponder these questions and share your thoughts. Do you believe that the discoveries made by Juno could redefine our understanding of plasma physics and magnetic interactions in the cosmos? Let us know in the comments below. Strange plasma waves detected over Jupiter's North Pole. Astronomers uncover a cosmic mystery over Jupiter's North Pole that could revolutionize plasma physics. NASA's Juno spacecraft, https://thedbrief.org/creepy-face-capture-on-the-Jupiter-by-NASA's-Juno- spacecraft, has detected an unusual new variety of plasma wave in its observations of Jupiter. https://thedbrief.org/ This has left us scratching our heads. NASA's James Webb Telescope uncovers unexpected light activity on Jupiter/ challenging long-standing ideas about the behavior of particles in the gas giant's powerful magnetic field. The strange plasma waves were spotted in Jupiter's magnetosphere, revealing a surprising new plasma behavior. https://thedbrief.org/new-research-solves-4-0-of-Jupiter's-X-ray-auroras that astronomers are having a hard time reconciling with existing models. This discovery, which has sparked debate among physicists, could redefine how we understand electromagnetic interactions in extreme environments. Since 2016, NASA's Juno spacecraft has collected vast amounts of data about Jupiter, its moons, and its rings. https://thedbrief.org/Jupiter's-moon-europa-remains-compelling-in-the-search-for-life-herace-y. During its extended mission, the spacecraft's orbit gradually aligned itself toward Jupiter's north pole, offering unprecedented views of the planet's high-latitude regions. This positioning allowed scientists to observe the magnetosphere in detail, revealing patterns that defy current theoretical predictions. Jupiter's magnetosphere, a cosmic enigma. Jupiter's magnetosphere, the region of space around the planet shaped by its intense magnetic field, is one of the most dynamic and mysterious structures in our solar system. Think of it as a vast, swirling pocket created by the planet's super-strong magnetic field, which channels charged particles from the solar wind into a protective shield. https://thedbrief.org/jupiters-magnetic-tornadoes-are-creating-mysterious-dark-reverse-aurora. This magnetosphere extends almost to Saturn's orbit and reaches nearly 7 million kilometers toward the Sun, making it the largest magnetosphere in our planetary neighborhood. Its size and complexity make it an ideal target for studying how magnetic fields interact with plasma and radiation. Strange plasma behavior, a paradigm shift. During Juno's observations, scientists noticed unusual behaviors in the plasma waves that don't align with what we expect from standard plasma physics. These waves, which are typically associated with electron oscillations, appear to exhibit properties of Langmuir waves, waves that usually resonate with ions. The discovery, detailed in a study led by Robert Lysak of the University of Minnesota, https://journals.aps.org/prl/abstract/10.1103/FN63-QMB7, suggests that under specific conditions, alphane waves, associated with ion oscillations, may behave like Langmuir waves, creating a so-called alphane-Langmuir mode. This hybrid phenomenon, described in Lysak's paper, challenges the conventional understanding of how plasma waves propagate. Normally, Langmuir waves oscillate parallel to magnetic field lines, but in these rare conditions, they seem to move perpendicular to them, even at frequencies below the ion gyro frequency. The observation raises questions. How can waves that are supposed to be governed by one set of rules behave in such a counterintuitive way? Could this discovery lead to new models of plasma behavior in extreme environments? Implications for space science. If confirmed, this finding could shift the foundation of plasma physics, particularly in modeling magnetospheres beyond Jupiter. The research team believes similar conditions might exist around magnetized stars or exoplanets with intrinsic magnetic fields, suggesting that this discovery could have practical applications in interpreting distant astrophysical phenomena. For example, understanding how these waves behave could help explain the behavior of auroras, radiation belts, or even the dynamics of interstellar plasmas. The study, titled New Plasma Regime in Jupiter's Auroral Zones, https://journals.aps.org/prl/abstract/10.1103/FN63-QMB7, was published in Physical Review Letters on July 16, 2025. Micah Hanks, editor-in-chief of The Debrief, highlights the significance of this work, noting that it could open new avenues for exploring the intersection of magnetism, plasma, and cosmic phenomena. But here's where it gets controversial. If this hybrid wave mode is indeed a new physical reality, does it mean that our current models of plasma physics are incomplete? And could this discovery lead to breakthroughs in technologies like fusion energy or space propulsion? These questions invite readers to consider the profound implications of this groundbreaking observation. Astronomers discover a mysterious new plasma wave orbiting Jupiter. Astronomers have made a thrilling discovery, a brand new type of plasma wave orbiting Jupiter, as revealed by NASA's Juno spacecraft. This groundbreaking finding introduces a wave phenomenon that has never been seen before in the cosmos, offering fresh perspectives on the enigmatic behavior of the gas giant's auroral plasmas. Researchers believe these newly identified waves are crucial to understanding the extraordinary auroras that light up Jupiter's poles, thereby enhancing our comprehension of the intricate space environment that envelopes this massive planet. Exploring the newly discovered plasma waves. Jupiter, renowned for its formidable magnetic field and vibrant plasma environment, has captivated scientists for years. The planet's auroras, which are stunning light displays encircling its poles, have been the focus of extensive research. While we are familiar with the auroras on Earth, those on Jupiter are significantly more intense and are shaped by the planet's expansive magnetic and plasma fields. Robert Lysak, a researcher from the University of Minnesota, along with his dedicated team, has made a remarkable breakthrough in this area. They discovered that the plasmas located near Jupiter's poles exhibit a completely new type of oscillation. These oscillations, or waves, are unprecedented and indicate that the charged particles and atoms surrounding the fifth planet behave in ways that remain largely mysterious to scientists. The role of Juno in this discovery. NASA's Juno spacecraft, which has been diligently orbiting Jupiter since 2016, has been instrumental in this discovery. Equipped with advanced instruments, Juno has collected invaluable data regarding the planet's magnetic field and its surrounding plasma environment. By analyzing this data, Lysak and his colleagues were able to observe the unusual behavior of plasma near Jupiter's poles. The research team concentrated on the ultraviolet radiation emitted near the poles, a vital aspect of Jupiter's auroras. They uncovered that the plasmas oscillate in a wave pattern that had not been previously recognized. This novel type of plasma wave opens up exciting avenues for understanding how Jupiter's powerful magnetic field interacts with the plasma that surrounds it. Why this discovery is significant. The identification of this new plasma wave is not merely an academic curiosity, it represents a significant advancement in our understanding of the broader dynamics of space weather. The auroras at Jupiter's poles are among the most powerful displays in our solar system, and deciphering the mechanisms that drive them could yield critical insights into the behavior of other celestial bodies with strong magnetic fields, such as Saturn and Uranus. Furthermore, this discovery enriches our overall understanding of space plasmas, which are essential components of the universe that influence everything from solar-wind interactions to stellar behavior. As Robert Lysak poignantly noted, terminating the mission just as it is yielding its most valuable data would be a true loss for our field. By investigating Jupiter's plasma waves, scientists can also enhance their understanding of Earth's own magnetic field and auroras, establishing connections between the two planets that were previously unclear. But here's where it gets controversial. How do you think this discovery will impact our understanding of other planets in our solar system? Are we on the brink of uncovering more secrets about the universe, or is this just the tip of the iceberg? Share your thoughts in the comments.